In today's session, we are going to learn chapter 2, Boolean Algebra. Yeah. So now here,
Just a second, sir.
yeah.
1 minute.
See, Boolean algebra is also called as switching algebra. There is a chance of asking question, what is the other name for Boolean algebra? Switching algebra is also called as Boolean algebra. Switching algebra or Boolean algebra. Now, we'll see this Boolean algebra is completely depends on the binary decisions. The decision will be having only two things, that is either true or false. Binary decision is going to be done based on the formula what we are applying to it. That is what we can say formula logic. Variable we are going to be considered, that is, let we consider x is a variable used in an algebraic formula that makes any numerical value with the real numbers. See, a variable used in Boolean algebra or Boolean equation can have only two possible ways or two possible values, that is true or false. See here, a variable used in Boolean algebra or Boolean equation can have two possible values, So one in that is true and the other one is false. True is going to be represented with 1, false is going to be represented with 0. True is going to be represented with 1, false is going to be represented as 0. See, now true and false will be considered as, see here we are having the sentence. That sentence can be determined to be either true or false or called logical statements or truth functions. See, what is meant by logical statements or truth functions? We have a statement. So with that statement, we can able to determine whether it is true or false. So that is called as logical statements or truth functions. See, the definition of this: sentences which can be determined to be true or false, that is called as logical statement or truth function. So this true and false also will be considered as truth values. True or false are called as truth values. So those are values what we are going to be get for making the binary decision. See, logical function or logic function, we can also say that is a compound expression. Now let me consider in general mathematics, x plus y is equals to z. This is a compound statement, or we can say x plus y into a. This is a compound statement. But whereas coming to here, logic statement or truth functions are going to be combined with the logical operators and or not, and or not. So and or not are the logical operators. These are the logical operators which are used to form a compound statement. So by using logical operators, will form a compound statement. Will form a compound statement or logical function. So example for that, x not y and z, a and c or b. So these are the examples what we are having for this. These are the examples what we are having for this. Logical operators will be used to form the compound statement in general mathematics. So these are all the algebraic variables. A, B, C, X, Y, Z, all these are all algebraic variables. All these are all algebraic variables. Most important 1 mark question. What is tautology? What is tautology? 1 mark question, most important one. Most important 1 mark question. See, after constructing the truth table, if the resultant column will be having all ones, then that will be considered as tautology. That will be considered as tautology. So whenever we have a logical statement or logical expression, in the resultant column of it, if we have always or all truths or ones, then that is tautology. If result of any logical statement or expression is always true or one is called as tautology. True or one is called as tautology. We'll see the answer for that. Most important 1 mark question. If result of any logical statement or expression is always true or one, is always true or one, so then that is tautology. 1 plus x is the example for tautology. Actually, this we have to say 1 or x. 1 or x. So r is going to be represented with this. We'll discuss about this. 1 or x is the example of tautology. So if they are asking what are the examples, then you have to write a example of tautology. 1 or x will be 1. So next, what is meant by fallacy? Opposite to the tautology. So if it is the logical statement result is always true or one, then that is a tautology. If result of any logical statement is false or zero, then it will be fallacy. See, this is also most important 1 mark question. Most important 1 mark question. Result of any logical statement is always false or zero. Is always false or zero. Example, we can say 0 and x. This is an example. How we are going to be considered, this is an example we will discuss, because still we didn't discuss the logical operators and or not. These two questions are most important for 1 mark. These two questions are most important for 1 mark. One more important question. What is meant by truth table? What is truth table? What is truth table? See, that is a table where it is going to be represents all the possible values of logical variables along with the possible results for the given combination of values. For the given combination of values, that is nothing but truth table. We'll see. This is also important question for 1 mark. It is a table which represents all the possible values of logical variables along with all the possible results. For the given combination of values. For the given combination of values. So I'll give one example here. X, Y, if we are taking two variables, X, Y, the possible, see, if it is a single variable, possible values. If for single variable, sorry, for one variable, possible truth values will be 0, 1. So if I'm taking X as a possible, X is a variable, its possible truth value will be either 0 or 1. Its possible truth value will be either 0 or 1. So for two variables, possible truth values are 0, 0, 0, 1, 1, 0, 1, 1. Two powers it is going to be get. How many values we have here? See, two variables, 2 power 2 will be getting 4 possible ways. When we have here 2 power 1, it is 2 possible ways. How many variables we have? That many 2 power n, where n is the number of variables. that many possible values we are going to be get in a truth table. That many possible truth values, that many possible values we are going to be get in that particular truth table. Next concept, we are going to be discuss about the logical operators. The first logical operator we are going to be discuss, that is not operator. The first operator we are going to be discuss is not operator. It is also called as complementation. Complementation. See, if x is a variable, if x is a variable, complement of x is represented as x bar or x dash. If x is a variable, the complement of x is represented as x bar or x dash. So like this we are going to be represent. Like this we are going to be represent. If x value is 0, then x bar will be 1. If x value is 1, then x bar will be 0. It means if x value is true, then complement innocence it will be false. If x is false, the complement of this will be true. So opposite to that. Opposite to that. That is not operator. Is it clear? Now, the truth table for not operator. Truth table of not operator. So we'll see x bar. X value is 0. If I'm taking, it will be 1. If I'm taking x value is 1, it will be 0. Truth table, the possible values we have to take and we have to draw the table. We have to draw the table. Next, Venn diagram. Venn diagram innocence. Venn diagram for representing the not operator. This is x. This is x complement. This is x complement. Is any doubt in this? Not operator?
No, sir.
The next logical operator we have AND operator. AND operator. See here, this is called as logical multiplication. Logical multiplication. AND operator is also called as logical multiplication. It is going to be represented with the symbol dot. Symbol for AND operation. Symbol for AND operation is dot. Symbol for AND operation is dot. See, x dot y will be read as x and y. It is read as x and y. Okay, now see here, rules of AND operation. rules of AND operation, how it is going to be work. 0 and 0 will be 0. See, one thing, if both the operands are 1, or if both the statements are 1, then only the resultant will be 1, otherwise it is false. If both the operands are 1, then the resultant will be 1, or otherwise it is false. See, 0, when we are considering two variables, the possible values will be 0, 0, 0, 1, 1, 0, 1, 1. So next combination is 0 and 1. Next combination is 1 and 0. Next combination is 1 and 1. So here in this possible case, here it will be 0. Here also it will be 0. Here also it will be 0. Because here, sorry, the last case, 1 and 1, it is 1. 1 and 1 is 1. If both the cases are 1, the resultant will be true. See, if both the statements are true or 1, then result of and will be true or 1. Will be true or 1. So we'll see the truth table for this. We'll see the truth table. Truth table x, y, x and y. So 0, 0, 0. Sorry, this is 1. 1, 0, 1, 1. So this is 0, this is 0, this is 0, this is 1. In this possible case, this is 1. When both the operands are true, then only the resultant will be true, or otherwise it will be false. Venn diagram for AND operator. Venn diagram for AND operator. See, here it will be, this is x, this is y. Only this particular part will be x and y. This is the Venn diagram. Only this is the particular part. This is a AND operator. Next operator we have here is under logical operators, OR operator. OR operator we have. Now see, this is also called as logical addition. This is also called as logical addition. The symbol of OR operator is plus. Okay, logical addition, logical OR. So x or y read as x or y. X or y read as x or y. Now see, the rules for this is 0 or 0 will be 1. Sorry, 0. If any of the statement is true, If any of the statement is true, then OR operator result is true. OR operator result is true. 0 or 0 is 0. 0 or 1 it will be 1. 1 or 0 it will be 1. 1 or 1 will be 1. So let me see the truth table of this. Truth table. When we are considering two variables x and y, x or y, that will be considered 0, 0, 0, 1, 1, 0, 1, 1. So if both are false, then it will be false. In other cases, it will be true only. In other cases, it will be true. This is a truth table. This is a truth table. Now, Venn diagram for that. Venn diagram for this. This is X. This is Y. Everything will come. This is X and this is Y. So everything will come. This is the shaded portion will be considered as X or Y. The shaded portion will be considered as X or Y.